Yo, yo, what up? Andrew here. Today I'd like to teach you how to use synthetic division to divide the following problem of x to the fourth minus 12x cubed plus 54x squared minus 108x plus 81. Oh, this should be fun. Oh, that rhymed. Plus 81. Oh, this should be fun. That's what actually happens when you start reading children's books. All right? You start rhyming everything without even knowing it. It's great. By the way, those books are fantastic. I mean, I haven't read... Who out there has read Bony Legs? I'd like to see. Nobody really read that book as a kid. And now that I look at it actually as an adult, I'm surprised I wasn't scared out of my wits. But that's what my parents subjected me to. That's maybe why I turned out the way I am. Thanks, Bony Legs. Anyway, you're going to take that and then divide it by x minus 3. So what you need to do, take a look at your dividend. That's the term here to the left of that division symbol. You're going to locate the highest power of x, and you're going to add 1 to it. What that will tell you in this problem, that will be 5. What that will tell you is it will tell you the number of columns you're going to need here inside of your synthetic division table. Now what you have to make sure of is that you have 5 terms, and which we do. In case one were missing, let's say the x squared term, by the way, you might notice that there's a trend, right? X to the fourth, x cubed, x squared, x, and then nothing. If you're missing one of those terms, all right, all you have to simply do is plug in a 0 and then whatever term was missing, x squared. Because 0 times anything is just going to be 0, and adding 0 to something doesn't do anything. But what the benefit is it will tell you the coefficient of that x squared term, which you need to know, and you're going to need to plug it in. So, in any case, we do have all 5, so take a look at the coefficient of your first term. That's going to be, and we always work from highest power all the way down to the constant, okay, by the way? So the highest powered coefficient here is going to be a positive 1. The next one is going to be a negative 12. The one after that is a positive 54. The one after that is a negative 108, and a positive 81. This should be fun. And now what you're going to do is you're going to take your divisor. Whatever your divisor is, you're going to take it and set it equal to 0. And what this will do when you solve that bad boy for x, what that's going to allow you to do is it's going to allow you to find the value you're going to need to plug in here on the outside of your table. Okay? Now once you have this top row filled in, you're going to follow a very simple series of steps. Take your first coefficient, drop it all the way down, right? Just rewrite it, okay? Whatever it is, it's a 1. Then you're going to take this number at the bottom, multiply by the number here on the outside, and whatever that result is, in this case it's a 3 times a 1, that result, which is a positive 3, will get plugged in here into the next adjacent cell. Then you're simply going to add these terms together. Okay, you're going to take a negative 12, add 3 to it, so that should be a negative 9. Then what you're going to do is you're going to take this value now, the new value down here at the bottom, negative 9, multiply it by the positive 3, this is still the outside value, and you're going to plug that result in, which is a negative 27. You're going to plug that result into the next adjacent cell. Then what you're going to do is that you're going to add these two together, okay? And that should work out to be now a positive 27. So then what you're going to do is you're going to take this value, 27, you're going to multiply it by the outside value of 3, and you're going to plug its result here in the next adjacent cell, which should be a positive 81. And then you're going to add these terms together. Okay, and when you add those terms together, you're going to get a negative now 27. And you're going to take that value then and multiply by the outside value. That's going to get you a negative now 81. Plug it into the next adjacent cell there, add those terms up in that column, and you get a 0. You're not guaranteed, by the way, to get a 0 here. You can get some number. It doesn't really matter, but whatever it is, don't fret, okay? Just plug it in. And now we have to keep in mind what these values represented, okay? These values will represent basically some of the coefficients of the remainder of your quotient. In other words, the quotient is going to be the result of when you take a dividend and you divide it by a divisor. Fun. So the first term here, always to the right, is going to be your remainder value. The next one is always going to be the constant. And now from here, there's a pattern. This will be the coefficient of your x term, this will be the coefficient of your x squared term, and this will be the coefficient of your x cubed term, however many columns you have. Now, there's one thing before we can finally declare that these terms right here, you're not going to do this to remainder, but that these terms right here are indeed the proper coefficients. You've got to go back to your divisor, and you have to locate the coefficient of your x term. In this problem, it's a 1. Now, whatever that coefficient is, I don't care. I want you to think about this. All right? I don't want you to do a problem without and forget this step. Because if the problem changes and this is a 2, it's going to totally change everything. All right? So in this problem, it's a 1. But what you're going to do with that 1 is you're going to go back and you're going to divide every single coefficient value except for the remainder. Do not do it to the remainder. You're going to divide each of those by 1. Okay? And if it were a 2 or a 3 or whatever the case is, right, you at least you know what to do. If this were like a 3x now minus 3, obviously this number over here would have changed, but that's not a big deal, right? I mean, you just do the math exactly how I stated out, whatever that works out to be. But if it were a 3, you would have divided now everything by 3, and this would have given now your new coefficient values. This would have been 1/3, this would have been -3, this would have been positive 9, that's a negative 9. All right, so those would have been the new values. Anyway, just writing this all back, that's x squared, and now x cubed. Now that we know we divided by 1, but it doesn't really do anything, now we can finally write our quotient. So you're going to take 1x cubed minus 9x squared plus 27x minus 27. Do not write 27c. That c represents a constant, meaning no x. Now plus, whatever the sign is here, that's what you plug in over here, okay? Plus now, and whatever this remainder is, you're going to put it up there, okay, above, and you're going to divide that remainder by your divisor, whatever it is. And here's now the answer. We can clean this up a little bit though. All right, so, you don't need to write the 1 there, so just write x cubed. Make it nice and pretty. Minus 9x squared plus 27x minus 27. And you don't need to write this because 0 divided by anything is just 0. So adding 0, like we said before, doesn't do anything. And guess what? Here's your nice polynomial quotient. All right? Guys, thank you very much for tuning in. I really do appreciate it. Please help us out if you can. Please like and subscribe. All it is just hitting a couple of buttons, and it helps us out tremendously. And if you don't, if that's too much work, that's fine. In conversation with your classmates, if you want to bring up our channel, we would be so appreciative of that. We really do want to help more people, and kind of our future is in your hands. All right? And we really, really, please, pretty please. Anyway, thanks for tuning in. I'd love to help you with more problems. Check out our channel. We have thousands of videos out there, and we solve specific problems. We'd love to help you with more. Be well.